Okay, we're going to be talking about radians and degrees, and the thing about radians and degrees is they are related, and we're going to figure out right now how they are related, how we can convert between the two, and how we can use that to solve some problems. So here we go, radians and degrees. What is a radian? In a circle, a central angle that cuts off an arc that is equal to the length of the radius of the circle has a measure of 1 radian. What does that mean? Here's what it looks like. If I've got the radius here of this circle, okay, I'm going to label it R, which is my radius of my circle. This sector here, or this arc here, is going to be labeled S. Okay, and so the angle that I'm talking about that's cut off is right here in the middle. Okay, so that's my theta. And I'm going to label the center here just with an O. Okay, so the radian is going to be equal to the radian measure of theta is going to be equal to the arc length over the radius. Okay, so that's the radian measure of our angle. Okay, so if the arc length happens to be equal to the radius, then that has an angle measure of 1 radian. Okay, so let's see how this translates for us. For example, I have this circle right here, and my theta is in the middle here, and I've got 6 centimeters for my arc and 3 centimeters for my radius. So theta in radians is going to equal 6 centimeters over 3 centimeters, which is equal to 2 radians. Okay? So that's how it works. That's as simple as it is. Okay, so when we explore the notation of this, theta equals 2 means it's 2 radians. 2 degrees, notice I've got the degree sign here. That means that it's 2 degrees. There's a very important distinction that needs to be made there as far as what the notation says. Okay, so let's just explore this for a minute. What if theta equals 1 full rotation? That means that theta is going to equal the circumference Okay, so the circumference of the circle, that's going to be all the way around. Well, let's look at what this actually means. That means that theta in radians is going to equal the circumference over the radius. Well, that's going to be equal to 2 pi r, which is circumference, over the radius. Well, I don't know if you can see what's going to happen here, but if these cancel out, then really I'm going to have 1 full rotation is going to be equal to 2 pi. Okay, so that's how this works. So that means that 360 degrees equals 2 pi, which means 180 degrees is going to be equal to pi. Okay, so that means that 1 radian is going to be equal to 180 over pi. And so that means that it's going to be equal to about 180 divided by 3.14. So it's going to be about equal to 57 degrees. Okay? So that's how this works. 1 degree is going to be equal to pi over 180. Okay? And so these are the basic things that we're working here. 1 radian is equal to 180 over pi. 1 degree is equal to pi over 180. These are going to be our conversion factors that we're going to use. This stuff here is also very important. Okay, so that's the important stuff. How do we use it? So 1 radian, like we said, is going to be equal to 180 over pi, and 1 degree is going to be pi over 180. Now, so we're going to convert 45 degrees to radians. So what we're going to say is 45 times, and 1 degree is equal to some number of radians. So what I'm going to do is I'm going to multiply by pi over 180. The key here is to say what units you want go on top. Okay, so in this case I want radians, so pi is going to go on top. Okay, so when I do this, I'm going to get 45 over 180 times pi. I'm going to reduce my fraction. So I know that 45 is going to go into 180. It's going to be 1/4 of our way there. So I'm going to have 1 over 4 pi, and that's going to be pi over 4. Okay, so you see how this works. So if I'm converting 45, so 45 degrees equals pi over 4 radians, because I multiply by my conversion factor. Let's look at another example. So now we're going to convert 450 degrees to radians. So 450, and what I want goes on top. 450 over 180 times pi. And I'm going to reduce my fraction here. Okay, so I've got 900 over 360. We'll skip this step. I wanted to bump it up one to give us a better idea. And so when I reduce this, I know that 90 is going to go into both. And so I'll reduce by a factor of 90. So this is going to be 5 over 2 times pi. Okay, it's that simple. This is what we're multiplying by. And so let's see what else we can do here. Pi over 6 to degrees. So once again, here I go. Pi over 6. I'm going to multiply by what I want. What I want is degrees. So I'm going to put my 180 degrees on top. My pi's cancel. I've got this equal to a fraction. My fraction is going to be 180 over 6, 30 degrees. Okay? It's a beautiful thing. This is how it works. All right? One more time. 4 pi over 3 times. What is it that I want? It's degrees. Okay? So when I'm going to cancel these things out, I've got pi canceling here, pi canceling here. I'm going to go on top with 4 times 180, but I'll divide this by 3. So I've got, this is 4 times 180 over 3. I'm going to do 180 divided by 3, which is 60. So I'm going to have 4, 240 degrees right there. Okay, so that's how we do this. So to convert from degrees to radians, we're going to multiply by 180. To convert from radians to degrees, we're going to multiply by 180 over pi. It's a big cyclical thing here. Okay?